Welcome everyone. Today we are going to discuss about the fuel cells. So what these fuel cells are or what is the use of these fuel cells that we are going to discuss very briefly in this seminar. So in the last you might have studied about the batteries, how the batteries are going to work, how you are going to generate the EMF from the batteries. So there in the batteries we know that they are nothing but the storehouses of the electrical energy, where in the sort of the electrodes, that is the chemical energy stored, and that chemical energy is going to convert into electrical energy from the redox reactions which is going to take place at their respective electrodes. So similarly we are going to generate the electrical energy in a fuel cell also. So how we are going to generate the electrical energy from these fuel cells, that we are going to discuss today. So what is a fuel cell? A fuel cells, of course, these are also the electrochemical energy conversion devices, that is it involves the conversion of chemical energy into electrical energy. That's why this is also an electrochemical device. So it produces electricity from external supplies of fuels and the oxidant. That is, here the fuel and the oxidant, that is usually normally the oxygen is used as an oxidant. So those are going to combine and going to generate the EMF, that is the electricity. These react in the presence of an electrolyte, that is the fuel and the oxidant. They are going to react in presence of an conducting, ionic conducting thing, that is the electrolyte. Generally the reactants flow in and reaction products flow out. The reactants are going to flow into the electrolyte and the products are going to flow out from the electrolyte, where the electrolyte remains in the cell. Fuel cells can separate virtually continuously as long as the necessary flows are maintained. So how these fuel cells are different from traditional conventional cells? So this is the thing about traditional conventional cells. In the traditional cells, what is going to happen is the chemical energy is not going to convert directly into electrical energy. So the chemical energy, first it is being converted into thermal energy, and then thermal to mechanical energy, and then mechanical to electrical energy. So in each conversion, that is the traditional conversion of chemical to electrical, in each conversion of energies, there is a certain loss of energies at each and every steps. So that is, say for example, if you take a water, so and if you heat it to generate the steam, that is the thermal energy is going to be generated, and from that steam you are going to run the turbine, that is going to be converted into mechanical energy. So by running the turbine you are going to generate the electrical energy. So in these steps, what is going to happen is at each and every step there is a loss of the electrical or certain chemical energy. So the efficiency of the traditional cells are less, whereas in fuel cell what is going to happen, there is no involvement of thermal or mechanical energy conversions. Direct chemical energy is being converted into electrical energy, that is the chemical energy of a fuel and the oxidant is directly converted into electrical energy. This is what exactly the main difference between the traditional and the fuel cells, traditional cells and fuel cells. So there is a reformer principle involved, so that in the reformers the fuels get reformed to generate the hydrogen fuel. So the respective fuel will be generated and it is separated, and that is used as a fuel for the fuel cell for the generation of the electricity. How fuel cells are going to work? The most suitable fuel for such cells, that is the fuel cells, is hydrogen or a mixture of compounds containing hydrogen, that is the hydrocarbons normally. A fuel cell consists of an electrolyte which is sandwiched in between the electrodes. The oxidant, that is the oxygen, is used as normally oxidant, which is going to pass over one electrode and hydrogen over the other, and they react electrochemically to generate electricity, water and heat. Many combinations of fuel and oxidants are possible. Hydrogen cell uses hydrogen as a fuel and oxygen as a oxidant. The other fuel cells are also there, where the hydrocarbons, where after the hydrocarbons usage there is the fuels, so they get reformed and the hydrogen will be produced from those hydrocarbons. And also the alcohols, in alcohol also we can get the energy. Other oxidants include the air, chlorine and chlorine dioxide is used as oxidant materials for fuel cells. How fuel cell is mainly different from ordinary batteries? Fuel cells differ from batteries in the way that consume reactants, which must be replenished, while batteries store electrical energy chemically in a closed system that we had discussed with respect to the batteries. Additionally, while the electrodes within a battery react and change as a battery is charged or discharged, a fuel cells, but in case of fuel cells, the electrodes are catalytic. The catalytic electrodes are used, and their electrodes which we use in a fuel cells, they are stable. They are not going to react. The advantages of a main advantage of fuel cell is their efficiency is very high. That is, the almost maximum percentage of conversion of chemical energy to electrical energy is possible in case of a fuel cells. They are eco-friendly, that is, no harmful waste products are going to be again formed as a byproducts are released into the atmosphere. That's why it is simply called as eco-friendly one. They can produce direct currents for long periods at a very low cost. Auto power efficiency comparison for a fuel cell, battery and a gasoline engines. So if you use a fuel cell, the system efficiency is 24 to 32%, electric batteries the 26%, and gasoline engine is about 20%. This is one of the fuel cell bus, EcoBus it is named as, where they use fuel cells for running. This is a symbol of a fuel cell vehicle where the hydrogen tank is placed there. You can just see the electric thing, current which is going to coming from here, and the motor will be there which helps in run. So this is one of the units of the fuel cell. So this is a car which is run with the help of a fuel cell. These are certain vehicles which are using fuel cells. This is a fuel cell bus. This is where you can see just here the hydrogen fuel cell bus, which is produced by Mercedes-Benz company. So where the setup of a fuel cell will be there, these are the hydrogen tanks which is placed here, and the fuel supply units will be here, where they are continuously going to give the fuels. If it is over, then fuel cells, this is a complete fuel cell. And air condition for cooling, as the energy is produced and the heat will be generated, so they must be cooled, so they are going to have a air condition. These are also certain fuel cell vehicles, fuel cell run vehicles. So these are the certain companies that is the marketing partners of fuel cell: FC Expo, New Japan Ecosystem, Cameron Carbon, Renew Transmit, MEFH, RIA, Fuel Cell Europe, Hydrogen and Fuel Cells Canada, and so on and so forth. And there are many types of fuel cells are there. The types of fuel cells are based again depending upon the type of fuel that you are using or the type of the electrolyte that you are using. So these are certain types of fuel cells: hydrogen oxygen fuel cell, methanol oxygen fuel cell, alkaline fuel cells, molten carbonate fuel cells, phosphoric acid fuel cells, solid oxide fuel cells, solid polymer electrolyte fuel cells, that is SPEFCs, and solid oxide fuel cells, they are also called as SOFCs, and the biochemical fuel cells, that is BFCs. Hydrogen oxygen fuel cells. Only the thing that we are going to discuss here is with respect to the hydrogen oxygen fuel cell. Whilst physicist William Root developed the first crude fuel cell in the year 1839. The first commercial use of fuel cells was in NASA, that is NASA space programs to generate the power for probes, satellites and space capsules. Fuel cells are used for primary and backup power for commercial, industrial and residential buildings and in remote or inaccessible areas. There are many types of fuel cells that we had seen earlier, but they all consist of an anode. All those fuel cells will be having the anode, which is a negative part, and the cathode, which is a positive part, and the electrolyte will be there, which allows the charges, that is the ions, to move between the two electrodes in a fuel cell. Electrons are drawn from anode to the cathode through an external circuit, producing the DC electricity, that is direct current, where as the main difference among the fuel cell types is the electrolyte. So fuel cells are classified by the type of electrolyte they use. So here in the last you can see this: the alkaline fuel cell or molten carbonate fuel cell, phosphoric acid, solid oxides. These are all based, the names are based upon the type of the electrolyte that you are going to use in that particular fuel cells. Whereas the hydrogen oxygen or methanol oxygen is because in the hydrogen oxygen fuel cell where the hydrogen is being used as a fuel, and in the methanol oxygen fuel cells the methanol is used as a fuel. Fuel cells come in a variety of sizes also. Individual fuel cells produce, that is a single fuel and a single oxidant they produce, so they can produce a very small amount of electricity, only about the 0.5 to 0.7 volts. So these are stacked. So to get a more EMF or a power output, so many fuel cells have to be combined or placed either in a series or a parallel manner to increase the voltage and current output to meet an application's power generation requirements. In addition to electricity, fuel cells produce water, heat, and depending on the fuel source, a very small amount of nitrogen dioxide is also produced. So, as these produces the water as one of the simple major byproduct, and also the carbon dioxide is also formed in a little ways, okay, in certain types of fuel cells. So these are not toxic, so that's why this is also called as eco-friendly, as I told you earlier. The energy efficiency of fuel cell is generally in between 40 to 60% or up to 85% efficient if waste heat, the heat which is going to form, is captured for use. The most important design features in a fuel cells are the electrolyte substance. As I told you earlier, electrolyte is one of the main important thing in a fuel cell. The electrolyte substance normally defines the type of the fuel cell. As I told you earlier, it's the fuel that is used along with the electrolyte. The main thing, one more main thing, is the fuel that we are going to use in a fuel cell. The most common fuel used in the hydrogen oxygen fuel cell is a hydrogen and the anode catalyst, which breaks down the fuel into electrons and ions. The anode catalyst is usually made up of a very fine platinum powder. The cathode catalyst, which turns the ions into the waste chemicals like water or carbon dioxide. The cathode catalyst is often made up of a nickel, where the anode is made up of a platinum. This is the schematic representative of a hydrogen oxygen fuel cell. So there you can see this is the hydrogen compartment, and this is the anodic, and this is the cathode, and here the oxygen will be supplied towards the cathode, hydrogen will be supplied towards the anode. And here when you supply the hydrogen at this anode, the hydrogen gets splits up, okay, and it undergoes oxidation, releasing the electrons, and there is a membrane here also, and it will allow only the ions to pass through it and not the electrons. These electrons which are formed here, they are going to move to the external circuit, and they are going to get reduced at this is a cathode, okay. These hydrogen ions and oxygen will combine here, and the oxygen gets reduced by using the electrons which is coming from the external circuit, and they are going to form the water, and this water along with the heat, this is going to come out. So it consists of two electrodes made up of porous graphite impregnated with an electrocatalyst. The most effective electrocatalysts disposed on graphite electrodes include alloys as platinum, ruthenium, cobalt, and platinum, ruthenium, nickel, which work at a higher temperature of 75 degrees Celsius. Those is used as a anodic materials normally. The electrodes are placed in a concentrated solution of KOH in a water. So here the electrolyte which we are going to use is a potassium hydroxide. This is alkaline electrolyte. Hydrogen and oxygen gases are bubbled through the anode and the cathode compartments respectively. So the gases diffuse through the electrode pores into the electrolyte. So this is how it is going to happen. You can see the fuel is going to come through the fuel compartment. This is the catalyst, that is the anodic, okay, and this is the cathodic thing. Here you can see the splitting of the hydrogen into H plus, releasing the electrons. These electrons are going to move through the external circuit, where this is going to get reduced this at this cathode to form the water. See the process. See once again the process. Yes. The reactions. The simple reactions, that is, at anode the hydrogen in presence of the electrolyte KOH, they are going to undergo oxidation to form the electrons, and at cathode the oxygen which is used as a main oxidant, so it is going to get reduced by using the electrons which are lost at anode, and it is going to form the hydroxy ions. The whole reaction is simple. The hydrogen and oxygen reacts to form the water molecule with a generation of a 0.5 to 0.7 EMF or volts. Water should be removed because water dilutes the KOH. As the major byproduct of this is the water. The water, once the water is formed, it should be removed immediately, because if it is present there, so there is a chance of diluting the potassium hydroxide, that is the electrolyte that you are going to use. The cell produces an EMF about 1.23 volts. Applications. This fuel cell is used as an electric power source for space vehicles, military and mobile power systems. First time this fuel cell is used in Apollo space program. And the advantages of this hydrogen oxygen fuel cell is there are no moving parts, it's reliable, and it is efficient, that is efficiency with respect to the energy conversion. And the heat generated can be captured for other uses also, and it will operate very cleanly, that is eco-friendly one. And one of the main disadvantages is the anodic compartment. We use a platinum, which is a bit costlier catalyst used there. This is one of the main disadvantage of these fuel cells. So this is a fuel cell bicycle. So thank you, dear friends. So I'll just come up with the another topic later. Thank you.